Aha! Okay, I've managed to switch to Chrome now. Somewhat with problems. Chrome really doesn't like me. In the hopes that now I do in fact have what is colloquially referred to as sound on the stream. That would be jolly. What a no idea. Okay, let's just pick a video. Oh god. Oh, I can't do that. I can't. I'm sorry. Let's first of all let's share the screen. Oh, I can share a. Oh, I can share a Chrome tab, but I can only share the tab. And when I share the window, the sound won't go with it, which is bizarre. So let us have a look. Please tell me this works.
You're in the JTron solar system, okay? Until a better name comes up, I can't believe.
Yes, it does. Hey, I can share just this one tab. So if I open a second tab, none of you can see it. I love that. Finally, I can do some streaming that works. All right then. All of you lovely one person that is watching, it was probably me on the phone. My phone has eyes, in case you don't know. I can actually do stuff. Just took me an hour. No, half an hour. About half an hour. So let us proceed very briefly. Okay, so what I thought I would do as a kind of test, I'd like to, because I mentioned this in a video, and I find that this is such a great example, and I find this to be one of the major discoveries that I have made about flat Earth is this very thing here. Just thinking about resizing this window here, but I don't want to touch too much because you see, the thing is I'm using one normal screen here. I think it has 22 or 23 inches, and I have a 19-inch screen here. That's an old office monitor. That the screen itself is fine. It is a 1600 by 900 resolution, so it's not the newest, but it's really fine. It's a fine screen. And I like using this kind of a little old, but not so old that it doesn't work, but so new that it just works. This is HD, you know. But I've had it, but I have it in portrait mode that I use for coding because I code a lot for my master's thesis and for adjacent projects. Yeah, so naturally. With Firefox, it wasn't a problem. With Chrome now, it is a problem, to no one's surprise. But yeah. Exactly. Great. With that said, I believe we can soldier on. Because I'd like to talk about something that I've realized in Flat Earth that these two gentlemen here show very nicely, but a lot of Flat Earthers, dare I say, a vast majority actually do that. And this is in regards to models, right? So let's go. They go through some calculations at the beginning.
I can move you a little bit out of the way here, though.
Where they go through, how far are they apart? How big should a sphere be in relation, or like the actual planet? So
we should only cover just the lower
centimeters would Mercury be if we put a certain distance away from the sun in a certain model, so at a certain scale, right?
Dissolve?
Yeah.
I don't dissolve. I just go like
that's
this.
essentially what this video is.
Mercury is to the sun right there. And so in this model that this guy has, Mercury is the scale is 1 centimeter. 1 centimeter.
So they scale everything according to Mercury. So Mercury, if Mercury was 1 centimeter in, I think it's diameter probably.
Right. That's point. That's
then they scale everything else in accordance with that.
3/8 of an inch for you Americans. It's just a hair over 3/8 of an inch, but it's pretty close. And so this is to scale the sun, and then Mercury right here. I mean, like, watch, I can't. right there. That's the closest I can show it to you. That's the scaled path. And then Venus out here obviously is, well, let's look at the size of Venus compared. We go here.
Venus, of course, being
Venus
bigger, I would have
would
estimated
then
by about
be
2 to 3 times. So this is
4.8,
quite a good
almost
guess of mine.
2.5 centimeters.
And,
Right.
and so on and so forth.
So that's
And-
unresolvable in the model that I have. Unresolvable. Earth would be 2.6
And they go on,
scale.
of course.
Can I get in closer than that?
Wow, and Jupiter's the giant gaseous space ball, right?
Yeah, so it's right at the edge of being resolvable.
And what I'd
I
like
was
to
able to get in a hair closer.
to talk about with that
I
is
can't see it.
why are they
I
talking
see
about
the
a real
arrow.
life model like that? It's not
Yeah,
a
I
secret
can't-
that the distances between stars are a lot
Different
bigger.
angle. Let me get a little bit
or
better
the
look
planets
on
in
this.
case. That
Well,
the
I mean, this
distances
is a good
between planets
opportunity
are a lot bigger than the planets. Actually, this isn't something new.
For me to let everybody know. So we're going to have to come up with some pretty amazing ways that people are going to be able to view this. So from the ground, looking up into the sky at the JTRON, it's 13
They call this device the Chatron.
miles across. Or sorry, it's 26 miles across. So we're going to have to come up with, and we're going to need help from people in the chat. If you want to leave a comment below, do we use giant elevators? Are we going to use helicopters, drones? How are people going to fly up and actually get close enough to see Jupiter and be able to zoom in on Jupiter? And then are we going to see what the sunrise would look like, or like what the
The thing
shadows or the
thing that,
you know,
that gets me is why
which
would you do
phase
any of
these
that?
different spheres are at?
It's not like we have a
Yeah, so
problem
then here's
with
Saturn out here.
modeling this
Saturn's
currently.
Saturn's way out there, which
There
is the
is good
slowest
freeware
of
that
the
can do
luminaries.
that. I
And,
certainly
then Uranus
if you
out here.
have a little bit more of a beefy computer, probably not nowadays, but when it came out, the Space Engine, I can for hobby astronomers, I can recommend Stellarium. We use Stellarium at the university for amateur kind of our own amateur observations. There is Solar System Scope, although I'm not a big fan of that. It seems cheap to me. I don't know why. But there are things that you can do, right? There are things that you can do that work as a model, but somehow, and this is one of the things that I realized, these people think that you need to be able to have a model that is literally a physical representation of some other process, right? And I find it bizarre. Why would you? But let's keep
Then
on going.
Neptune out here, Pluto right here, and then this would be the edge of the Aries scattered disk. And so all of those things come from this table right here. Obviously, I didn't do the asteroid belt.
Yeah, I know,
and
that's fine.
Pluto, I mean,
We
you saw
don't
that
need
it's
to
not
say
even, none of these things are resolvable. Jupiter, we can't.
So let's
Snow
move on.
would be a problem, like trying to be able to clear this off, right?
Huge
Right, so-
problem. Huge
Yeah.
problem. We'd have to make it heated,
Snow
right?
would not be the main problem.
so I just
if
want to show
someone
everybody
was to
that,
build this for some
the
reason
width-
or another. Why
width
would you
of
do
the-
that? No,
We're going to do a circular
would
one
be
because the
problem,
solar system
Um,
is circular, and
and
adding the extra corners is going to add so much cost to the project.
Wasted space, really. And somebody brought up in the chat, it's worst. Gloofers are thinking that it needs to be a curved screen. Well, guess what? Their supposed ecliptic solar system is
Plane.
it's on a flat plane. So yeah,
it's not exactly flat. It's somewhat close to flat. And this has to do with the way that solar systems or stars, technically stars, evolve, right? This is something to do with that because when stars form, first you have a very big cloud. This was the topic of my master's thesis, actually. So you have the right person here. So when stars first form, before they form, they are essentially as some of you may know, stars form in gas clouds, and this gas eventually collapses due to the pull, kind of, if you will, of its own gravity. Then there are counteracting forces like the radiation pressure and just pressure in general. Some clouds then collapse, some don't. Yada yada yada. But as you go on, eventually, if your cloud collapses, It forms something that will be a star in the future in the center. And surrounding it, all of this material is brought towards the soon-to-be star. And the cool thing about that is, anytime a lot of material is transported into somewhat little space, which certainly is the case for a star, an accretion disk forms. We see this with black holes, we see this with stars. You can see accretion disks even forming in smaller scales. And the cool thing about this is stage of star formation. Out of this debris disk, our planets form, or not in the late stages, but somewhere in the mid to the late stages of the star forming process. Our planets form, and they form out of an already existing accretion disk. So then it is not a surprise that they all orbit in roughly, it's not exact, but then this isn't a surprise anymore, right? So I can actually, maybe I can show that to you. Hang on just a second. Ooh, Jesus Christ, I can't type today. Well, I mean, I say today. I've never been able to be a particularly good typer. I really don't like Chrome. I don't like Chrome. I don't want to use Chrome. But Chrome is the only one that will give you lovely... I point there because this is my control monitor. That will give you lovely people, or you lovely people technically, audio. So of course, I'm hard pressed for options, you know. Anyhow, by the way, if you want to talk about anything, or if you want me to have a look at stuff, feel free to write in the comments. It's not like there are a lot of people here that I could talk to in the comments, so feel free to say something. I mean, it's not the nicest picture. Maybe I should. Maybe I should. Yeah, this is a little better. This is a little bit better. Not perfect, but a little bit better. I will open this here. Don't worry, I know that you're not seeing anything. I'm just picking the best or the better pictures. Oh, this is one of the ones I wanted. Yes, very good. I will stop sharing here, and instead I will very much share on right here. Exactly. So here you can see it, and it makes somewhat sense, I think, that the closer ones have a higher inclination of their ecliptic plane. And so you can see, for example, Mercury has 6 degrees off the rest of the plane. And here you can see for all the planets. And when he just said that they are all moving in a flat disk, well, it's not perfect, but it's somewhat of a disk, as you can see here. Well, here you can't. And this is why there is a certain band in the sky where you can always see the stars, the planets. The planets will never be over here. They will always be along the ecliptic, because this is where the solar system formed, right? When you star formation, when you have well, that was way too general. What was a this is one of the more nice ones. I was hoping that I would find one of the ones that are similar to the one I used in my thesis, but alas, I don't, and I can't show you the one from my thesis because it is copyrighted, I believe. So yeah. Anywho, this is a rather nice depiction that I have open here. So you have dark clouds in dense cores. This is a little bit more detailed than what I just explained. You have a gravitational collapse. Please note that even though those two pictures are the same size, this is roughly like a tenth or 100th, maybe somewhere in between, of this here. And then you form a protostar, and you have this accretion disk. And out of this accretion disk, planets form, and you can actually look at planets form, kind of with ALMA, the Atacama Large Millimeter Array, where you can literally see things like that, and it blows my mind. It is so amazingly cool. Look at that. This is a star in the center here. You cannot see my mouse. Why? Why can't you see my mouse? Oh, that is so annoying. I apologize. Okay, in the center, the bright yellow spot in the center is actually what will very, very soon be for astronomical timescale soon, be a star. This is a class 3 or type 3 young stellar object. And you can see this will soon be a star here, somewhere in the middle. And the rest here surrounding this material is the debris disk, that in which you can already see kind of the areas that have been picked clear of material, because they have already started or are already in the main stages of planet formation. And this is where you see those already missing rings almost. This looks a little bit like the rings of Jupiter. And this is because more or less the same thing is happening here, just in reverse. Where with Jupiter, the moons were too close to Jupiter and got ripped apart and essentially turned into little rocks. Here the opposite happens. The little rocks can coalesce together and form planets. And this is what is going on here, right? And this is why the solar system appears to be on but of course it appears to be in a flat plane in
Elliptic plane.
The ecliptic plane. It's not ecliptic sphere, right?
Yeah. So this width across here is like 26 miles. Everybody,
in
26 miles.
model.
There it is, the JTRON, and you can see below. There's Vegas, and so from
Yes,
the
there is Las
sphere, you know
Vegas.
where the sphere? Where's the spear? The spear in Vegas.
Mhm.
If we go from the spear,
I've got it down here. So this is like the hotel strip where all the casinos and stuff are, and so this is where the sphere is, and so we've got a top-down view of it when it was under construction from Google right here, and then we have a side elevation that is like we're looking out towards the north.
there's the sphere.
And so
There's the north view.
So look at this. Look at it. Look at this. This is great. So here's the view of the sphere, and then as you can see, the whole entire horizon is going to be the JTRON. It's going to be the heliocentric solar system.
Let's go ahead and envision ourselves right over here by the sphere, looking to the north like this. And then we put up the screen that's 26 miles in diameter, 13 miles in radius.
and
This thing, it's going to be the tallest thing on Earth by a long shot, because
certainly
Mount Everest
it would come with its own
is 30,000 feet.
big
And if we
problems
go
in
up here, we've got
regards
some
to building
stats.
safety.
Got some stats up here at the
Um,
top we want to take a look at. And
So they
what we've
talk on
got
a bit,
here,
about that. Just hang on a second.
bunch of different vantage points. But right now we're just sort of showing you the scale that we're going to have to
So
go ahead.
yeah, the pixels, the size. Another interesting, really, really funny, ridiculous fact. They've come up with names for everything. Right? Who knows what the name of our solar system is? Can you put it in the chat?
It's Sol, actually, which is some language.
Put it
I
in the
believe
chat
Greek.
if you know what the
or-
name
or
of
sun,
Earth's
I think.
solar system is.
First of all, it's
right?
an Earth solar system.
You'd think that
you
these-
name solar systems after their primary star, right? So it's not Earth solar system. Earth isn't a star, but
geniuses that come up with everything. Our nearest one, I believe, is called Andromeda.
Andromeda
there's-
is a galaxy, not a solar system. The next solar system over is Proxima Centauri.
Solar system or galaxy or other galaxy. So what's the name of our solar system? I wanted to let's see if anybody has an answer to that.
Again, it's
Yeah.
Sol. You know that from science fiction, of course.
So
But
let's take a look at
I'm
how
just
this
waiting for
thing
them
would actually
to come to the point
scale up
that I would like to talk
on
about.
Earth. So right here
This is
is Las
poorly prepared.
Vegas, and you can see this
I'm aware.
circle that I have drawn
aware.
on the ground
Camera's
right here.
here.
That is
Too.
the same
It's not here. It's here. Camera's here.
same radius, right? So it's 13 miles in radius, 26 miles in diameter, and then we were talking about with the amount of square feet that this has, how many square centimeters that is,
Not exactly.
and that's going to be our
important,
pixel count, because we have to have
they
at
have
least
one
one
pixel,
pixel
every
to represent
centimeter and so on.
Mercury. Right, so
Can you say that again slowly? I really want people to understand. So, just to have Mercury be how many pixels?
One
One-
pixel
for-
being 1 centimeter.
Well, to create the screen that we're looking at here, this is to scale. So when someone like Jeranism, you're going to hear later say, yeah, this model is to scale. So to actually show a computer screen with a model to scale, you have to have it be 26 miles in width. And we do have an answer. Solid Tank actually got the correct answer of all the dumbass things that the heliocentrists have come up with. They named our solar system the solar system. I mean, as if they couldn't make it
technically,
more
it's-
geocentric. Like
It's usually solar.
I mean,
but yeah.
why do we call it the JTron solar system? I mean, if no one's named it, let's name it JTron. You're in the JTron solar system, okay? Until a better name comes up, I can't believe that they didn't even name. Why would they not come up with a cool, like, heliocentric name for our solar system? Some Roman god or something, right? Lucian or something. No, nothing. It's called the solar system. Get out of here. So again, for Mercury to be 1 pixel in size, the outer reaches of our solar system that takes us to what is that belt called? I had it pulled up, but I was checking the solar system's name
Kuiper belt.
to get to
Mm-hmm.
is it the Kuiper belt?
Maybe.
So the
on what you're
Kuiper belt
talking
is
about.
There it is,
supposedly
Eris. So
out
to,
near Pluto, but then there's the Eris scattered disk.
so to
they
get to
say.
the scattered disk, to have a correct, this is your working 2-scale model. Can we go back to the JTron, please?
Yeah.
To have Mercury be 1 pixel, and that's the circle that's concentric right around the sun, you have to have a 26-mile monitor. Do you want me to repeat that again? And this is 2 scale. This is heliocentric model. If you want to show how the
Oh, I'm sure it is.
heliocentric they call it the solar system works. The solar system.
But this is the
You
point.
have to have it
This is the
26
point.
miles, and then can you read the pixel
No,
size?
you don't. If you want to understand how it works, you can look at all of these things in separate. Why do you think I need to look at all of it at the same time? And this has eluded me from the very beginning when I started doing videos about flat Earth. I did not know this until I had that thought when I made the video about models like a month ago or two.
Size again? How many pixels? So to make this screen, and again, Jason said it would be way too expensive if we tried to make the 4 corners. We're just
Yeah.
going to make it circular. We're going to get into other interesting things, how we're going to power it. We're going to start talking about, so this thing's a giant wind sail. We're also going to have to come up with an ingenious design to allow wind to pass through it. And actually, that might be a good way to power it. So again, can you let us know? So the pixels,
Is
because we don't believe in atoms here. Okay. If you want to know,
Which is let's not even talk about that. They probably wouldn't appreciate that I do my master's thesis at the physics department in nuclear physics. Then, right? I imagine that would be a problem.
the truth, everything that we have in this virtual reality in the world is measured in what's pixels. It's not measured in atoms. Okay,
If
no
you
one
say
can
so.
measure in atoms. So can you?
I disagree. We can literally count atoms at the place where I do my master's thesis. You could see atoms with an electron microscope.
Can you continue and explain to me the pixel size?
Yeah, so for each pixel, we'll do being 1 centimeter. So let me show you the idea that I have for how we're going to do this. So this is to scale right here. Each one of these circles is 1 centimeter in this scale. So if we get LED lights that are 1 centimeter in diameter, right, and we put them together in these panels like this, we're going to get 900 per about square foot. So I've got some ideas where if we keep the LEDs sort of recessed a little bit, then if we have a grid work of metal around here, what it'll act is like a polarizing filter, because one of the things that we're going to have a big problem with a screen outdoors like this is
So
getting
many things
reflections
would
off
be
the
a problem with that.
you won't be able to see it
you know.
outdoors, right? So we're going to need to have some sort of a polarized screen so that that big screen isn't just reflecting and burning people up and all that kind of.
The magnification of
I'm
the
not-
sun
I'm not sure if
reflecting
that
off
would
of it's
happen,
just going to
actually,
cook
but,
Vegas. So what I find ingenious here is that you actually have spaces around the corners of the pixels, right?
Yeah, so-
Go ahead.
The design here, the idea is because you could stack these closer to each other if you move these over a little bit, because the circles will get nestled to each other a little bit closer. But what we're going to need is for the ability for air to pass through this, because being 13 miles in radius or 26 miles in diameter, it's going to catch a lot of air, especially up at the elevations that we're going to be getting to with this thing, right? So let's go back here, and
so there is someone in the chat said that Donald Trump is proposing to rename the solar system the American solar system. That was a good one. Well said.
That is genuinely funny.
All right. So with these stats up here, we have it's 136,745 feet in diameter, which means that if we put the bottom edge of the screen right down to the ground right here, right, that up at the top of the screen here, we're going to be up at 136,745 feet. I mean, there's some special things that we have to take into consideration about being at those elevations, right?
Yeah, well, we're going to have pressurized suits. We're going to have oxygen tanks. We're going to have basically a spaceship to get you up to the top. Now, I mean, what are we going to put on the outer reaches in Eris? It's supposedly just dust, right? So if you want to get up to the top and you want
do it rappelling style,
repelling,
they'll put on, in order to get this screen to the size that we need to be able to show these things to scale, it's got to be 136,740 feet tall. So
do that to scale.
Watches the screen, of course.
Gets me so much.
So one of the places.
Are you talking about JTron subscription fees? So
anyway, this is something that gets me. They think we need to have an actual physical model that represents everything that the globe does, and I think it's so kind of funny to me that they think to do that, as if they have a flat Earth model that could do that. By the way, but it eludes them that you could break this up into several different pieces that each can work together. But of course, if I just want to know, I don't know, something about gravity, I don't need like how something will be gravitationally attracted on like a kilometer from the Earth's surface. I don't need to know about the position of the stars, for example. And these are the things that really get me, and I don't know what to do with them and why things like that can occur. But I mean, it is first of all a bad misunderstanding of the word model. But I've talked about this in my other video. Yeah, it's not easy. I also think it's a little bit sad that currently there aren't that many videos coming out from flat earthers now, or at least not from the ones that I have access to, that I watch. And I think that's very sad, because I'd like to do some more content these days, but I can't. I'm limited by lacking flat earther content, actually. But yeah, this is just my Olaf Does Astro channel. Of course, I have a separate channel in which I watch other stuff, but I don't want to talk about that. But I think it's so funny that the most things that happen now is essentially just talking about the final experiment, which is understandable, but it's also a little bit sad if you want to do content about that, right? And I check that they're going that many places, I think. Yeah, I think in terms of streams, since no one is watching, I'd leave it there. I'm need to do something else now, I'm afraid. But yeah, in case you are watching, thank you very much, and I will see you in another one that will hopefully be a little bit better prepared.